The movement of an object. Wow, that is very descriptive and so helpful. I don't know, let's imagine that it is a projectile. I don't know, what sport do you play? You're throwing something or hitting something in the air. And it's recorded from the time it passes a fixed point. All of that tells us is there's a starting position, right? After t seconds, it has a certain speed, which is given by this function. Use calculus to find how long it takes to reach an acceleration of 2.8 meters per second squared. Alright, so we're given speed, or rather the equation for speed at any given time, and we're looking for acceleration. So this is a kinematics problem because it's dealing with motion, right? Speed and acceleration. So a handy little thing to remember to relate displacement or distance, speed, and acceleration is this little diagram. So to go from distance to speed, we differentiate, right? Speed is the rate of change of time. Similarly, acceleration is the rate of change of velocity. Right, so if we differentiate velocity, we will get acceleration, because acceleration is the change in speed over the change in time. So, to answer the question, we need to find the acceleration function, so a of t, which is equal to the derivative of the velocity function, right, v prime of t. So that first line I wrote was just acknowledging that acceleration is equal to the derivative of velocity, right, or the speed. Alright, so now let's work that out. So we looking at the first term, power of 2, multiply out the front, so 2 times 0.5, which gives 1. T to the power of 2 minus 1, so subtract 1 off the power, just gives 1. And when we have power of 1 and coefficient of 1, we don't need to write that to keep it nice and tidy. Now the derivative of minus 2t is minus 2, right? Because t to the power of 1, the 1 multiplies out the front, which gives minus 2. We subtract 1 off of 1, which gives 0, and t to the power of 0 is 1. So we're left with minus 2. Alright, so we found the equation that models acceleration by differentiating the equation that models speed. Rereading the question, it asks us to find out how long, so that's the time, it takes to reach a certain acceleration. Well, we have an equation now that relates acceleration and time. So let's substitute 2.8 in for acceleration and then solve for the time it takes. So adding 2 to both sides, we get time is equal to 4.8 seconds. Awesome. So just to summarize, firstly, we acknowledged we were given speed and we were looking for acceleration, so we needed to differentiate, right, to find acceleration. That was step 1. And if we did that correctly, that is actually an achieved skill. Now step 2 was to use that equation and the information we were given about acceleration, so substituting in 2.8 in for acceleration and solving for t, which would then be the merit component.